Hey guys, today I will show you how to find the inverse of a matrix. And first of all, what is the inverse? So basically it's another matrix, and typically it's denoted by A with -1 superscript. And if you multiply your matrix A by this inverse matrix A to the -1, that gives you the identity matrix. So identity matrix, it's a matrix that has ones on this main diagonal, so from the right top to the left bottom, and other elements, they're just zero. And also if you multiply them in the reverse order, so the inverse matrix by the matrix A, so it still gives you this identity matrix. And another thing to keep in mind, that inverse matrix sometimes inverse matrix does not exist. So it doesn't exist for all matrices. And also keep in mind that inverse matrix can be found only for a square matrices. So a matrices that have the same number of rows and columns. The inverse matrix exists only if the determinant of your matrix is not equal to 0. The fancy words, these matrices called non-singular, so their determinants are not equal to 0. So here's the rule. So in order to find the inverse matrix of a given 2 by 2 matrix, you need to find 1 over basically the reciprocal of the determinant. So this vertical bar, so basically it's the same notation for the absolute value of a number. So we usually use the vertical bar, or sometimes it's written DET, which is abbreviation for the determinant. So either way is fine. So you take the reciprocal 1 over the determinant of this matrix A, and you multiply it by this new matrix. Sometimes it's called the adjoint matrix. If it comes to this, all you do is just swap these elements on this main diagonal. Look, this A and D basically they swap their position, so D comes on the place of A, and A takes the spot of D. And these two elements B and C, they remain the same, but they becomes negative. So these elements have this negative in front. So this is your inverse matrix. So let's put it to the test. Say you need to find the inverse of this given matrix A, 3 minus 5, 1, 2. First thing to do for all of these problems, check to see does the inverse exist. As I mentioned before, sometimes the inverse matrix does not exist. And in order to check if the inverse exists, so all you do is just take the determinant, find the determinant of the given matrix. So, and all it means is just you rewrite your matrix using this vertical bar, so could basically you skip over this step. So recall that the determinant of a 2 by 2 matrix. So all you do is just take the elements on this main diagonal, so 3 and 2, and you multiply them through, so 3 times 2, and you subtract off those elements on the other diagonal, so 1 times -5. That gives you the determinant. So all you need to compute, 3 times 2 give you 6, and minus 1 times -5 gives you +5. So your determinant becomes 11, so it comes out to be 11. So it's not equal to 0, so your inverse matrix does exist. And by the way, if you need extra help with finding the determinant of 2x2 matrices or 3x3 matrices, so I have a separate videos on this, and the links would be down below in the description box, so you could go ahead and use these links and check them out. Now this is your determinant. Now go ahead and write the inverse, so A with this negative superscript. So all it does is, first of all, you need to take the reciprocal, so 1 over of the determinant of this matrix. So the determinant is 11, so 1 over 11 gets multiplied by, so we're going to construct, let's say, this adjoint matrix. So all that means, we're going first of all to swap these two elements, so 2 goes on this place and 3 goes over there, and these elements, they remains the same, but we're going to swap their signs, so negative 5 becomes positive 5, and this one becomes negative 1, and basically we're done. Not yet. So all you do is just take this 1 over 11, so basically this is a scalar in fancy word, or just a number, a constant, and all you do is just multiply this number by this matrix. So all that means that you need to multiply each element in this matrix by this number. And by the way, I do have a separate video on this kind of scalar multiplication, if you will, and the link also would be down below in the description box, and if you are down to this, go ahead and check it out. So, and finally your inverse matrix becomes, so all you do is just multiply by this element. So your scalar happens to be just this kind of a nasty and awkward fraction, but we can't help it, so you would write just fractions as your element. So 5 over 11, negative 1 over 11, so it's not that neat and integer numbers, you know what I mean, 3 over 11. So that's your final inverse matrix for that matrix A. Alright, and by the way, you could check out your answer. If you take this matrix A and you multiply it by this matrix A to the negative 1 superscript, so you should be left with a identity matrix, as I mentioned before. So I mean, if you have time, if you are like to check it out, so go ahead and feel free. Or also you could swap the order, because hopefully you know that for matrices in order, when you multiply matrices, order does matter. So if you swap the order, generally the resulting matrix could be different. So also in this case, if you multiply the inverse matrix by the original matrix, you should be left with the identity matrix. Alright, with this being said, huge thanks for watching. I hope it has been helpful to you. Train your brain, and again, many thanks for watching. I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you will not miss out my new videos. If you will.